Congrats on getting this far. You're over halfway through the course and so close to completing the program. In this section, we'll cover ways for you to harden your networks. Network hardening is the process of securing a network by reducing its potential vulnerabilities through configuration changes and taking specific steps. In the next few lessons, we'll do a deep dive on the best practices that an IT support specialist should know for implementing network hardening. We'll also discuss network security protection along with network monitoring and analysis. There's a general security principle that can be applied to most areas of security. It's the concept of disabling unnecessary extra services or restricting access to them, since any service that's enabled and accessible can be attacked. This principle should be applied to network security too. Networks would be much safer if you disable access to network services that aren't needed and enforce access restrictions. Implicit deny is a network security concept where anything not explicitly permitted or allowed should be denied. This is different from blocking all traffic, since an implicit deny configuration will still let traffic pass that you've defined as allowed. You can do this through ACL configurations. This can usually be configured on a firewall, which makes it easier to build secure firewall rules. Instead of requiring you to specifically block all traffic you don't want, you can just create rules for traffic that you need to go through. You can think of this as whitelisting, as opposed to blacklisting. While this is slightly less convenient, it's a much more secure configuration. Before a new service will work, a new rule must be defined for it, reducing convenience a bit. If you want to learn more about how to configure firewall rules in Linux and other implementations, take a look at the references in the supplementary reading. Another very important component of network security is monitoring and analyzing traffic on your network. There are a couple reasons why monitoring your network is so important. The first is that it lets you establish a baseline of what your typical network traffic looks like. This is key because in order to know what unusual or potential attack traffic looks like, you need to know what normal traffic looks like. You can do this through network traffic monitoring and logs analysis. We'll dive deeper into what network traffic monitoring is a bit later. But let's quickly summarize how logs can be helpful in this context. Analyzing logs is the practice of collecting logs from different network and sometimes client devices on your network, then performing an automated analysis on them. This will highlight potential intrusions, signs of malware infections, or atypical behavior. You'd want to analyze things like firewall logs, authentication server logs, and application logs. As an IT support specialist, you should pay close attention to any external-facing devices or services. They're subject to a lot more potentially malicious traffic, which increases the risk of compromise. Analysis of logs would involve looking for specific log messages of interest, like with firewall logs. Attempted connections to an internal service from an untrusted source address may be worth investigating. Connections from the internal network to known address ranges of botnet command and control servers could mean there's a compromised machine on the network. As you learned in earlier courses of this program, log and analysis systems are a best practice for IT support specialists to utilize and implement. This is true, too, for network hardening. Logs analysis systems are configured using user-defined rules to match interesting or atypical log entries. These can then be surfaced through an alerting system to let security engineers investigate the alert. Part of this alerting process would also involve categorizing the alert based on the rule matched. You'd also need to assign a priority to facilitate this investigation and to permit better searching or filtering. Alerts could take the form of sending an email or an SMS with information and a link to the event that was detected. You could even wake someone up in the middle of the night if the event was severe enough. Normalizing log data is an important step, since logs from different devices and systems may not be formatted in a common way. You might need to convert log components into a common format to make analysis easier for analysts and rule-based detection systems. This also makes correlation analysis easier. Correlation analysis is the process of taking log data from different systems and matching events across the systems. So if we see a suspicious connection coming from a suspect source address in the firewall logs to our authentication server, we might want to correlate that logged connection with the log data of the authentication server. That would show us any authentication attempts made by the suspicious client. This type of logs analysis is also super important in investigating and recreating the events that happened once a compromise is detected. This is usually called a post-fail analysis, since it's investigating how a compromise happened after the breach is detected. Detailed logging and analysis of logs would allow for detailed reconstruction of the events that led to the compromise. Hopefully, this would let the security team make appropriate changes to security systems to prevent further attacks. It could also help determine the extent and severity of the compromise. Detailed logging would also be able to show if further systems were compromised after the initial breach. It would also tell us whether or not any data was stolen, and if it was, what that data was. One popular and powerful logs analysis system is Splunk, a very flexible and extensible log aggregation and search system. Splunk can grab logs data from a wide variety of systems and in large amounts of formats. It can also be configured to generate alerts and allows for powerful visualization of activity based on log data. You can read more about Splunk in the supplementary readings in this lesson. Flood guards provide protection against DOS or denial of service attacks. Think back to the CIA triad we covered earlier. Availability is an important tenet of security and is exactly what flood guard protections are designed to help ensure. This works by identifying common flood attack types like SYN floods or UDP floods. It then triggers alerts once a configurable threshold of traffic is reached. There's another threshold called the activation threshold. When this one is reached, it triggers a pre-configured action. This will typically block the identified attack traffic for a specific amount of time. This is usually a feature on enterprise-grade routers or firewalls, though it's a general security concept. A common open-source flood guard protection tool is Fail to Ban. It watches for signs of an attack on a system and blocks further attempts from a suspected attack address. Fail to Ban is a popular tool for smaller-scale organizations, so if you're the sole IT support specialist in your company or have a small fleet of machines, this can be a helpful tool to use. This flood guard protection can also be described as a form of intrusion prevention system, which we'll cover in more detail in another video. Network separation, or network segmentation, is a good security principle for an IT support specialist to implement. It permits more flexible management of the network and provides some security benefits. This is the concept of using VLANs to create virtual networks for different device classes or types. Think of it as creating dedicated virtual networks for your employees to use, but also having separate networks for your printers to connect to. The idea here is that the printers won't need access to the same network resources that employees do. It probably doesn't make sense to have the printers on the employee network. You might be wondering how employees are supposed to print if the printers are on a different network. It's actually one of the benefits of network separation, since we can control and monitor the flow of traffic between networks more easily. To give employees access to printers, we'd configure routing between the two networks on our routers. We'd also implement network ACLs that permit the appropriate traffic.